Hello, Dr. Bill here. We're going to take a look at Sohcahtoa today, some important trigonometry for ACT and SAT. And Sohcahtoa confuses a lot of people, but it really shouldn't. So we'll just do a quick Sohcahtoa lesson here, and then we're going to take a look at the problem. When I do Sohcahtoa, I like to separate it like this, just so that everything is clear. And so stands for the sine, and the sine is going to be equal to the opposite side over the hypotenuse, right? So if we look at this, here's the angle in question. The angle in question is always the reference point. So here, our x is the angle in question, and the opposite side would be the side, obviously opposite this angle. And the hypotenuse is always opposite the side of the side opposite the 90, right? Okay, so here clearly we don't know the base and the height. We'll have to figure that out. But here we'll just start with the Sohcahtoa, right? Okay, the cosine is going to be equal to the adjacent side over the hypotenuse. Now, adjacent just means next to. So here we have the angle, x, and the side next to the x is this base, right? And then the hypotenuse is here, again, opposite the 90. And then the tangent equals the opposite side over the adjacent side. So here again, with x as our reference angle, the opposite side is the height, and the adjacent side is the base, right? So let's see what's happening here in this problem. It says, in the pictured triangle, the sine of x equals 0.8, and the cosine of x equals 0.6. What is the area of the pictured triangle? So once again, we're going to need the base and the height in order to figure this out. Okay, so let's start with the sine of x, right? So we said just a moment ago that the sine, sometimes that's written with or without an e, it doesn't matter. The sine equals the opposite side over the hypotenuse. So we just put opposite over hypotenuse, right? Now here, the opposite side, we don't know, right? So let's put a question mark there just to show that we don't know that, right? The hypotenuse is 10, okay? Now we know that this is equal to 0.8. Okay, so that means that our opposite side, let's call it x, right, over 10 equals 0.8. Well, we want to know what x is, right? So let's multiply both sides by 10. And then these 10s cancel. And then we get x equals 0.8 times 10, which is simply 8, right? So that means that this side, the height, is 8. Okay, now we need the base, right? And there are three ways to know this. One way would be the Pythagorean theorem that we could do. A squared plus 8 squared equals 10 squared. Then we eventually solve for the base. The other way could be just using this information that the cosine of x equals 0.6. And I'll show you an easy third way at the end of this problem. But let's do it here. Let's say that the cosine of x equals 0.6. And we've said here that the cosine equals the adjacent side over the hypotenuse, right? So here, adjacent over hypotenuse. We know the hypotenuse is 10. The adjacent side we don't know. And here that's going to equal 0.6. So I think we could see here, if we go down here, that, let's call it again, x over 10 equals 0.6. Well, then we would multiply both sides by 10. That cancels, and we get x equals 6. So here the adjacent side is 6. Okay? Now you may recall that we find the area, what is the area of the pictured triangle, by simply multiplying the base times the height base times height divided by 2. Okay, well, here our base is 6, our height is 8. We divide that by 2, and that's going to be 48 divided by 2, which is simply 24. So our answer here for the area of the triangle is 24. Okay? There is another way to know this, which really could have been instantaneous. We have what we call Pythagorean triples, right? Which would be basically the Pythagorean theorem in very common combinations, right? And one is the 3, 4, 5 triangle, right? When, say, the base is 3, the height is 4, the hypotenuse is going to be 5, right? We probably notice that that would be exactly 1/2 of what we have here, which is the 6, 8, 10 triangle, right? And then if we multiply 3, 4, 5 by 3, we get another common combination, which is 9, 12, 15. And then the other two very common ones are the 5, 12, 13, and the 7, 24, 25. So for the ACT and SAT, I do recommend that you memorize these combinations, commit them to memory, and then recognize them when they come up, because they can allow you to get answers quickly and easily like you could have here. Because when I started, I knew the hypotenuse was 10, and I saw these values. I knew right away it would be a 6, 8, 10, and the area would be 24. But again, this is just a helpful hint, okay? I hope you found this lesson on Sohcahtoa valuable. If you did, please subscribe to my channel, like the video, share with anyone that you know could benefit from this lesson, and hit the bell icon so that you can be notified of all future videos. This is Dr. Bill again, and have a great day. Thank you.